line, and then you have another line, and you have an intersection. Do you understand? So angle is what? Is formed. So the kind of angle that is now formed is not based on what you want to call it. Do you understand? Intersects, or the intersection of lines form an angle. Forms an angle, I mean. That is, when two lines come either like this or like this, an angle is what? Is formed. So now we now have types of what? Angles. Types of angles. We have acute. Acute angles. These are angles less than what? 90 degrees. Such as this. Okay? Right angle. Of course, that is your theta is equal to 90 degrees, and it is depicted as this. Okay? These are what? Your right angle. Anytime you see this figure, especially this description, then it means what? A right angle. You know, if you are being a good listener of commentators of football, they will tell you that, and the player plays the ball at the right angle. They are trying to paint a picture that is, even if you are listening, but you are not watching. They are trying to paint a picture like you have your goalpost like this, and then maybe the ball is being placed there, and this is your goalkeeper. Two stretches. Do you understand? So this is what? Right angle, 90 degrees. This is also what? Right angle. Right angle and right angle. Is that the key? Good. So it's 90 degrees. The right angle is formed when the vertical line meets with what? An horizontal line. We have types of line. This is a vertical line. This is not a vertical line. This is horizontal, but this is not. Or may I say this is not against this. Are you with me? So anytime vertical line meets with horizontal lines, then the right angle is formed, such as corners of the houses. Corners of walls, they are right angle. Why? Because this is vertical and this is what? Horizontal. So this is right angle. Right angle. So this is right angle, right angle, right angle. So it is found to be 90 degrees, equal to what? Using your protractor. Now if you now have something greater than that, then you are going to have obtuse. Obtuse angle, of course, are angles that are greater than 90 degrees or less than what? 180 degrees. From here now, if I have this, I have this, and this is going to be my what? Obtuse. Is that the key? Here, this was what? Acute. Why? Because it's not up to what? 90 degrees. But now, this is what? If you pick your zero from here, so this has to be what? Obtuse. Because if I put the right angle here, it's greater than what? The right angle. 90 degrees. Then we have reflex angle. That is, this angle are greater than 180 but less than what? 360 degrees. A good example, do you have an angle that is greater than 180, less than? Yes! You even have some angles that are greater than what? 360. But how will you go about that? We are going to look at that. Okay, now you assume that this is your straight line. And we say sum of angles in a straight line is what? 180 degrees. Very, very good. Now, if you now have an angle like this, more than more than your what? 180. More than, it has passed the straight line. So such angle is what? Is reflex. So this is a reflex angle. Okay? So this is an example of a reflex angle. From here. Now, someone now asks, what is the value of an angle greater than 360 degrees? Then you have a cycle. You have a what? A cycle. This, if you have like 370 degrees, this angle is equal to 10 degrees. It's equal to what? 10 degrees. How? Because if you have to show this on a pole, you pick your 0 from here and then you go like this. That's your 360. And then of which you have an excess of 10. Did we get this? 360 is what? Angle at a point. But what do you have? So you have an additional one. 10. Is that the key? So that means 370 degrees implies what? 10 degrees. You can even confirm that using your trigonometry ratio. If you press sine 310, so 370, it is the same value you get when you press sine 10. Either cosine or tan. Is that the key? So if I say what is the value of angle of 780 degrees, then it shouldn't be shifting. Shouldn't be what? Shifting. Just count the cycle of 360 from what? 780. Is that the key? The remainder is going to be your what? Your value. If you are confused, make your research. Now, that's it. Then what are other things that you need to know? The relationship of these angles based on lines, alright? That is when we have an introduction of transverse lines on other lines. Okay, look at this situation. Let's start with this. This is a straight line. Are you with me? And then you have another line crossing the straight line. Okay? So we call this A and we call this what? B. And we say A plus B is equal to what? 180 degrees. Why? The sum of angles in a straight line. Likewise, if I try to extend this, then I can have this as x and I have this as what? Y. Also, I am going to say that, excuse me, x plus y is what? 180 degrees with the same reason. Likewise, you can say x plus b is equal to what? 180 degrees with the same reason. And you can as well say a plus y is equal to what? 180 degrees. Why? We are still talking about what? Straight lines, sum of angles. So which means if you have something like this, in as much as they meet at the point of incidence. The sum of this will equally give you 180 degrees. That is, if you have A, B, C, and D. So you have A plus B plus C plus D. All must give you what? In as much as they are lying on the what? In the what? The straight line. No matter how much the value, in as much as they are still in the straight line, still 180 degrees. And then we call that, of course, maybe let's call it angles in a straight line. In, on, I don't know, maybe your research, or it's in. Then the next one we have here is when you have a line like this, and then you have transverse lines. Okay, before that, we have another line crossing it. And I call this A, I call this X, I call this B, and I call this Y. I am going to say I have what's called vertically opposite what? Angles. What do I call it? Vertically opposite angles. It means I know you are aware that A plus X is 180. A plus Y is 180. B plus Y is 180. Likewise, X plus B is what? 180. But in this light, vertically opposite angles, we are concerned with what? With opposite angles that you have at this point of intersection. It means we have X is the same thing as what? Y. Also, A is the same thing as what? B. This rule is referred to as what? Vertically opposite angles. They are equal, and sometimes they are depicted with this. Okay? You know, when we say vertically opposite, you know, in mirrors, we say one of the features of a plane mirror is what? Is laterally inverted. Like this, if you have something like this, and this is your P, you are going to have this on the other side. Are you with me? Meaning that this angle is still what? This angle. So they are vertically opposite. Alright, the next one is when we start seeing corresponding angles. Now, that is when you have parallel lines. You have what? Parallel lines. This is how to depict parallel lines. You are always with arrows. Okay? In some textbooks you see double arrows. In some you see single arrow. Meaning that they are still parallel. Is that okay? Now, when we say parallel lines, of course, these are lines that will not meet no matter how long or vast you extend them. They will never what? Cross. And they will maintain the same locus all through. When I say locus, I mean the intervals with which they are differentiated will be uniform all through. Is that okay? Very good. Now, study this. Look at this line. Are these parallel lines? No. Why? Because they are still going to meet. When you continue to extend this, so you can assume that it's going to what? It's going to meet. Is that okay? So because of that, this is not a what? A parallel line. So when you now have that, when you continue the extension and in no way cross, you don't have any cross, then that is what? those are parallel lines, so to say. Now, you don't have any angle here. But by the time you have a line crossing these parallel lines, we call such line transverse what? Line. We call it what? A transverse line. Any line that crosses parallel lines is called what? A transverse line. Then what is going to happen? Let's start with corresponding angles first. It means, sorry, I need to show you a true picture. Now, this is equal to this because it corresponds. It's what? It corresponds. That is, this is just like this. So if this is x and this is what? Y. This is A and this is B. Then x is equal to, and A equals what? Likewise, if this is G and this is V, then G is the same thing as what? V. Why? Because they are correspond. Look at this situation. We have parallel line, we have parallel line, we have parallel lines like this, and then you have just one transverse line across. So it means this corresponds to this and this corresponds to this. Do you understand? So the angles will be equal automatically. Likewise, you have this, and this. Likewise, this, and this, and as well this, and this. So now here, this is equal to this is equal to this. On what rule? Vertically opposite angles are equal. Now, I said this is the same thing as this. On what rule? Corresponding angles are equal. And I said this and this will give you 180 degrees. On what rule? Sum of angles in a triangle, in a straight line is equal to 180 degrees. And when you sum up all this, then we call it sum of angle at a point, which is 360 degrees. So please don't. And then you have a transverse line. On the account that these lines are what? Are parallel. So which means it's not true for lines that are not what? Parallel. That is, you have transverse line on two lines, but they are not showing. What I mean is, you have a line like this, another line like this, I now have this, I now want to apply this rule. It's wrong until you have to see a picture like this. Or double, it could be double, it could be single. Meaning that they are parallel lines. Is that taken now? So please be mindful. Some of these figures you have in your questions, they are not meant to design, not for design's sake, not to make it look attractive. No, they have their mathematical meanings. Is that taken now? So please, let's look out for that to avoid errors. Now, look at what you have. This is transverse line crossing two parallel lines in terms of alternate angles. So if this is x and this is y, so what happens, class? Then x equals what? Y. On this rule, the alternate angles are equal. Likewise, if this is p and this is q, then p is equal to what? Q. Why? Alternate angles are equal. So here, what are my alternate angles? Here, from here, what are my alternate angles? X and V, thank you. And then, if I have maybe M here, what's my alternate angle here? A and M. Is that taken? So please, let's look out for this. After that, then we have what's called complementary angles. Complementary angles. This is it. you have sum of all the angles, that will give you 90 degrees. Then we say the angles are what? Complementary. They are what? Complementary. Please, let's not forget. Anytime, instead of having sum of angles to be 180 degrees, I call angle of what? Sum of angles in a straight line. But that of 90 degrees is what? Complementary. So we say that A complements BC, B complements what? AC, and C complements what? AB. Why? Because when you add C to AB, you get 90. When you add A to BC, you get 90. When you add B to AC, you get what? 90. Is that taken now? Good. Then another thing is supplementary angles. I'm supposed to have explained that on sum of angles on a straight line. But then, let me see. Please stand to correct me for my spellings. Is this correct for supplementary? The spelling? Okay, let's carry on. Now you have single P. Is it? Okay, thank you. Now, this is M, of course. When you have this, we still have A plus B plus C plus D equals what? 180 degrees. Now, D is supplementary to C, B, and A. A is supplementary to what? B, C, and D. C is supplementary to D, B, and A. Likewise, B is supplementary to what? A, C, and D. That is, when you consider an angle together with other angles and you get 180 degrees, then those angles are what? Supplement. Is that taken now? So don't mistake complementary for what? Supplementary. Then don't mistake corresponding for what? Complementary. Is that taken now? We have seen corresponding, complementary. So after this now, let's now see some other things. Another time we are going to look at circle geometry. Is that taken now? That's another concept. But if you have a very good idea from Euclidean geometry or geometry of angles and lines, then you don't have any problem on circle geometry. No, you understand?